Centripetal force is also called as radial force. It is called as radial force. Now here, centripetal force is the force which is acting along radius and toward the center of the circular path is called as centripetal force, and this force is responsible for keeping the object in moving circular motion. So this is necessary force for the circular motion. Now here, this centripetal force is given by a formula. You know that by Newton's second law of motion, F is equal to ma. So F we can write centripetal force, m is the mass, a is the centripetal acceleration. And centripetal acceleration formula is we already learned. It is v square by r omega square or v omega. These three formulas we learn. If I substitute the first formula, we get mv square by r as a centripetal force. If I substitute second formula of the centripetal acceleration, I get mr omega square as a centripetal force. If I substitute mv omega, we get mv omega as a centripetal force. Now example, you can see the example number 1. For circular motion of electron around the nucleus, centripetal force is provided by electrostatic force of attraction. The necessary force in that case is called as a centripetal force. When electron is revolving around the nucleus, the necessary force is electrostatic force of attraction. So therefore, it is providing, this electrostatic force provides the centripetal force for that circular motion. Another example is for circular motion of object tied to a string and revolve in horizontal circle. Centripetal force provided by tension in the string. Third example, for car traveling around a circular horizontal road with uniform speed, the necessary centripetal force for negotiating the curve is provided by force of friction. You know that without force of friction on the curve path, it's very difficult for a vehicle to take the turn. So necessary force in that case is the centripetal force, and the necessary force in case of vehicle traveling on curve path is a friction.